Okay, so we're going to work through this problem and see how you did. First thing you want to do is always to read and annotate the problem so you can understand what is the question asking you to do and what information do you need in order to do that. So we have this quilt pattern made of polygons and we can use a coordinate plane to plan our quilt. So the first thing that we're being asked to do is to graph. So we need to graph this pentagon, and they've given us the 5 points. So this is number 1. Graph the pentagon. Then we're going to graph another pentagon, and they've given us the steps. So second, I'm going to translate my pentagon 4 units to the left. And that's going to give me the prime, right? A prime, B prime, C prime, D prime, E prime. Then a third thing I need to do is I need to rotate my pentagon 90 degrees counterclockwise, and that will give me my double primes. It's a second transformation, so I've got 2 primes. So what information do I need? Well, they've given me everything. I need to know how far am I translating, 4 units, and I need to know how am I rotating 90 degrees counterclockwise. So let's go ahead and see our first step, what that looks like. And I have the steps here again, just so I don't forget. So I just need to graph this pentagon. So point A is at 8, 0. I'll label that with an A. Point B is at 6, negative 2. Point C is at 6, negative 6. Point C. Point D is at 4, negative 4. And point E is at 4, 0. So I can't use a protractor on this, so I'm going to do my best to connect the points, and you just go in alphabetical order. So A to B, B to C, C to D, D to E, and then connect it by doing E to A. So here is our original pentagon. I'm going to switch colors, and now we're going to translate it to the left by 4. So each point is going to move 4 spaces to the left. So A is now 1, 2, 3. A prime is where E was. B is 1, 2, 3. Here is B prime. 1, 2, 3. C prime. 1, 2, 3. D prime is on the axis. And E prime is also on the axis. Connect these points, so A to B, B to C, C to D, D to E, and then close it with E to A. So I have the same exact shape, same exact size, just shifted 4 units to the left. Going to change my color one last time for our final transformation, which is 90 degrees counterclockwise. Now, when you are rotating 90 degrees, you have to remember the rules to follow. And the rule is that your X and Y coordinates are going to switch places. So now I need to write all my ordered pairs for my new pentagon in red. So I will do that here. So I have A prime, B prime, C prime, D prime, and E prime. So A is at 4, 0. B is at 2, negative 2. 2, negative 6. 0, negative 4. And the origin 0, 0. So when I rotate them 90 degrees, the X and the Y are going to switch places, okay? So I'm going to do that first. So now it's going to be 0, 4. And I don't worry about signs yet, okay? So I'm going to forget that that's a negative. So this is going to be 2, 2. And this is going to be 6, 2. And 4, 0. And 0, 0. Now, how do I know if the X and Y's are positive or negative? Well, just a quick refresher. These are my quadrants. And the image starts down here in quadrant 4. And if I am moving counterclockwise, 90 degrees moves it one quadrant, and in the direction it's going to end up in quadrant 1. Okay? Since it's ending up in quadrant 1, X and Y are both positive here, so my X's and Y's here are going to stay positive. So these are the new points for my final pentagon. So let's go ahead and graph that now. So A is now at 0, 4, A double prime. B is at 2, 2. C is at 6, 2. D is at 4, 0. And then E is still at the origin. So I will do my best to connect these points. A to B, B to C, C to D, D to E, and then E to A. So I have the same pentagon. It's just undergone 2 transformations, okay? So I started here with the blue, and then we translated, and finally we rotated to get our shape up here. So the next, it's still the same shape, right? It looks like it's the same size, but we need to prove it. In math, you've always got to prove it. So I'm going to look at some corresponding sides to make sure that nothing changed and no sides got longer or shorter than what they started off with. So if I start off, and I'm just going to find some points that aren't so messy to look at, and let's use black now. So if I look at BC in the original, it is 1, 2, 3, 4 units. BC in the final pentagon is still 1, 2, 3, 4 units. If I look at A to E in the original, it's 1, 2, 3, 4 units. A to E in the final is 1, 2, 3, 4 units. E to D is also 4 units, and in the final it is still 4 units. So yes, my final pentagon in purple is the same size and the same shape because all of the corresponding sides are still the same measurement. So the distance was preserved. The question is asking us, is pentagon, our final pentagon in purple, is it the same size and shape as the original? So I have preserved the distance of all those sides. So yes, my shape is still the same size. So to explain this in a complete thought, pentagon, the double primes, is the same size and shape as pentagon, the original, A, B, C, D, E, because all of the corresponding sides are equal in measure. Period. I could have also measured the angles, but we don't have our protractors and everything, so we'll just stick to side lengths. Now you're going to move on to your Google form. You're going to complete a few practice problems and then your exit ticket.